Humankind has always looked up at the stars and wondered about our place in the universe. One celestial body in particular has captivated our imaginations for centuries: Mars. Its distinctive red hue sparked curiosity and fueled countless tales of Martians and alien life. Today, the dream of reaching Mars is a tangible goal pursued with increasing urgency by both government agencies and private companies. Why Mars? Despite its harsh conditions, Mars offers a potential lifeboat for humanity. It presents an opportunity to answer fundamental questions about our place in the cosmos. The challenges of colonizing Mars will force us to develop new technologies and a deeper understanding of ourselves. This instinct to explore compels us to reach for the stars. The journey to Mars will test human ingenuity, courage, and resilience. Private companies like SpaceX are investing heavily in developing the technology needed for human spaceflight to Mars. This is a global endeavor, a testament to human collaboration and our shared desire to reach beyond our earthly cradle. The dream of colonizing Mars is no longer a distant fantasy. Journeying to Mars demands a complete transformation of our space travel technology. The emergence of private companies like SpaceX has revolutionized the space industry with reusable rockets. SpaceX's Falcon 9 and Falcon Heavy rockets are designed to return to Earth and land vertically, allowing for multiple launches. This breakthrough opens up a new era of space exploration. Reusable rockets represent a paradigm shift in space travel technology. SpaceX's Falcon 9 and Falcon Heavy have proven their reusability with numerous successful launches and landings. SpaceX is developing Starship, a fully reusable spacecraft designed for interplanetary travel. This shift towards sustainability is crucial as we strive to become a truly spacefaring civilization. Generating sustainable energy is crucial for Mars colonization. Solar power presents a viable solution for powering spacecraft on their journey to Mars. Scientists are exploring alternative energy sources for Mars, such as nuclear power. Small modular nuclear reactors could provide the consistent power needed to sustain a Martian colony. Creating a self-sustaining environment on Mars is crucial. In situ resource utilization focuses on using resources found on Mars to sustain human life. Martian soil contains water ice, which can be extracted and purified for drinking and generating oxygen. By harnessing the resources available on Mars, we can create a self-sustaining outpost. SpaceX, founded by Elon Musk, has taken audacious steps towards making Mars colonization a reality. Their rapid development of reusable rocket technology has drastically lowered the cost of spaceflight. SpaceX's plan hinges on developing Starship, a fully reusable spacecraft designed for interplanetary travel. They envision a future where Mars is home to a thriving colony. Starship represents a paradigm shift in spacecraft design. This two-stage spacecraft consists of a massive booster stage, Super Heavy, and the Starship spacecraft itself. Both Super Heavy and Starship are designed to return to Earth and land vertically. Starship is envisioned as the workhorse of SpaceX's Martian ambitions, turning the dream of colonizing Mars into a reality. NASA, laying the groundwork. While SpaceX is spearheading Mars transportation, NASA focuses on scientific exploration and future human missions. With decades of experience, NASA's contributions are invaluable to understanding Mars. Robotic missions provide crucial data about Mars. These rovers act as our eyes and ears, collecting invaluable data. NASA is researching technologies for human life on Mars. This includes life support systems and resource utilization. The Artemis program is a stepping stone to Mars. NASA and SpaceX share the goal of expanding humanity's reach. While SpaceX and NASA may seem like competitors, their relationship is one of collaboration and mutual benefit. SpaceX pushes the boundaries of space travel technology, while NASA provides crucial research and expertise. This partnership is vital for human missions to Mars. Together, they are paving the way for a sustainable human presence beyond Earth. The journey to Mars is not a sprint, it's a marathon, a long and challenging endeavor. SpaceX is making significant progress with Starship, and NASA's Perseverance rover is collecting samples. The countdown to Mars has begun. With each passing day, the dream of walking on the red planet edges closer to reality. Imagine waking up to the soft glow of a blue-tinted LED sun, mimicking Earth's circadian rhythms. Inside a Martian habitat, the air is clean and temperature-controlled, a stark contrast to the harsh conditions outside. Breakfast might include protein bars made with Martian-grown algae. Then, it's time to don a sleek, lightweight spacesuit for work outside. Stepping onto the Martian soil, colonists tend to crops in a pressurized greenhouse. Others engage in geological surveys or expand the habitat. Communication with Earth, though delayed, allows colonists to share their experiences. Life on Mars would be a delicate balancing act, a constant negotiation between the need for self-sufficiency and reliance on technology. The habitats, likely built using a combination of prefabricated modules sent from Earth and materials harvested on Mars, would serve as sanctuaries from the unforgiving environment. Within these pressurized domes, colonists would create a semblance of earthly life, growing their own food in hydroponic farms, recycling water and waste, and generating their own power using a combination of solar and potentially nuclear energy. 3D printers, a staple technology in this Martian frontier, would be used to create tools, spare parts, and even personalized items, reducing the reliance on shipments from Earth. Venturing outside the habitat would require meticulous planning and precautions. The thin Martian atmosphere, offering little protection from harmful radiation, necessitates wearing protective suits at all times. Rover expeditions, essential for exploration and resource gathering, would be meticulously planned and executed, with safety being the paramount concern. Despite the challenges, there's a certain romance to the pioneer spirit that would define life on Mars. The shared experience of building a new home on a distant planet would foster a strong sense of community and camaraderie among the colonists. They would be bound by a common purpose, driven by the spirit of exploration and the desire to make humanity a multiplanetary species. Building a new life on Mars wouldn't just be about technological prowess. It would also require fostering a strong sense of community and shared purpose among the colonists. Isolated from Earth and facing unique challenges, the first Martians would rely heavily on each other for support, camaraderie, and the preservation of human culture and values. Within the confines of the Martian habitat, social interaction would be crucial for maintaining morale and psychological well-being. Shared meals, movie nights, games, and celebrations would help recreate a sense of normalcy and provide opportunities for connection. The development of Martian traditions and rituals, unique to their experience, would further solidify their identity as pioneers. Education would play a vital role in the Martian colony, not just for children born on Mars, but also for adults. Lifelong learning, with a focus on skills essential for survival and sustainability, would be paramount. Imagine workshops on hydroponic farming, lessons on robotics and 3D printing, and even classes on Martian geology and astronomy, all conducted under a salmon-colored sky. The cultural landscape of Mars would be as diverse as the colonists themselves. Artists, musicians, writers, and storytellers would play a vital role in documenting the Martian experience, capturing the challenges, triumphs, and unique beauty of life on a new planet. Their creative expressions would serve as a bridge between Earth and Mars, sharing the Martian story with the world. While life on Mars would be demanding, there would also be opportunities for leisure and recreation, albeit adapted to the Martian environment. Imagine gazing up at a pink-hued sky, the two moons of Mars, Phobos and Deimos, appearing as faint dots in the twilight. Stargazing on Mars, unobstructed by a thick atmosphere, would be a breathtaking experience, revealing a tapestry of celestial wonders. Within the habitat, virtual reality technology could provide immersive entertainment, allowing colonists to experience the sights and sounds of Earth, from the bustling streets of New York City to the serene beaches of the Maldives. Virtual reality could also be used for educational purposes, allowing colonists to virtually explore historical sites, visit museums, or even attend concerts and sporting events. Physical activity would be crucial for maintaining physical and mental health in the lower gravity environment of Mars. Indoor gyms could be equipped with specialized exercise equipment designed for Martian gravity, while outdoor recreational areas, perhaps enclosed within pressurized domes, could offer opportunities for Martian sports and games. The development of Martian tourism, though a distant prospect, is an intriguing possibility. Imagine adventurous travelers embarking on a journey to Mars, experiencing the thrill of space travel, and marveling at the ingenuity of the Martian colony. This influx of visitors would not only bring much-needed revenue, but also foster cultural exchange and strengthen the ties between Earth and Mars. While the allure of Mars is undeniable, its embrace remains a hostile one, presenting a myriad of challenges to human survival. The Red Planet, with its thin atmosphere, frigid temperatures, and lack of a global magnetic field, poses significant threats to human health and well-being. The Martian atmosphere, composed primarily of carbon dioxide, is unbreathable for humans. Its thinness also provides little protection from harmful solar and cosmic radiation, constantly bombarding the surface. Temperatures on Mars fluctuate wildly, plummeting to minus 140 degrees Celsius or minus 220 degrees Fahrenheit at night, and averaging a frigid minus 63 degrees Celsius or minus 81 degrees Fahrenheit throughout the year. The lower gravity on Mars, about 38% that of Earth, while offering a sense of lightness, poses long-term challenges to human physiology. Extended exposure to reduced gravity can lead to muscle and bone loss, cardiovascular problems, and other health issues. Addressing these physiological challenges will be crucial for ensuring the long-term health and well-being of Martian colonists. The Martian soil, while potentially fertile with the right treatment, contains perchlorates, toxic chemicals harmful to humans. These perchlorates would need to be removed from the soil and water before they could be used for agriculture or human consumption, adding another layer of complexity to the challenge of self-sufficiency on Mars. Perhaps the most insidious threat to human life on Mars is the constant bombardment of radiation from the sun and deep space. Unlike Earth, with its protective magnetic field and thick atmosphere, Mars offers little natural shielding from these harmful rays. Exposure to high levels of radiation can damage DNA, increasing the risk of cancer and other health problems. Protecting Martian colonists from radiation is paramount, requiring innovative solutions for both short-term missions and long-term habitation. Short-term missions could rely on radiation shielding incorporated into spacecraft and Martian habitats. These shields, made from materials like water, polyethylene, or even Martian regolith, can absorb and deflect a significant portion of incoming radiation. For long-term habitation, more sustainable solutions are needed. One intriguing possibility is to establish Martian settlements underground, utilizing natural caves or lava tubes as shelters from radiation. Another approach involves developing artificial magnetic fields around habitats, creating a protective bubble against harmful rays. The scarcity of resources on Mars necessitates a radical shift in our thinking, from a mindset of consumption to one of conservation and resourcefulness. The Martian colonists, at least in the early stages, will rely heavily on resources sent from Earth, a costly and unsustainable model for long-term survival. The key to establishing a permanent human presence on Mars lies in mastering the art of in situ resource utilization, or ISRU. ISRU focuses on identifying and utilizing resources readily available on Mars, reducing dependence on Earth, and paving the way for self-sufficiency. Water ice, found beneath the Martian surface, is a valuable resource. It can be extracted and purified for drinking water, and through electrolysis, split into its constituent elements, hydrogen and oxygen. Oxygen is essential for human breathing, while hydrogen can be used as fuel or combined with carbon dioxide to create methane, another potential fuel source. The Martian soil, while challenging, can be enriched and used for agriculture within controlled environments. Waste products from human activities and plant cultivation can be recycled and repurposed, creating a closed-loop system that minimizes waste and maximizes resource efficiency. Section 4. The Psychological Frontier, the Human Element. Beyond the physical challenges, colonizing Mars will push the boundaries of human psychology. The isolation of living on a distant planet, the confinement of habitats, and the constant pressure of survival in a hostile environment will test the resilience and adaptability of the human spirit. Selecting the right individuals for a Mars mission will be crucial. Psychological screening, focusing on factors like resilience, adaptability, teamwork, and stress management, will be essential for building a crew capable of handling the psychological demands of a Martian mission. Maintaining mental health during the long journey to Mars and throughout their stay on the planet will require innovative solutions. Virtual reality technology could simulate Earth-like environments, providing a sense of connection to home. Therapeutic interventions, tailored to the unique stressors of Martian life, will also be crucial for supporting psychological well-being. The success of a Martian colony will depend not just on technological prowess, but on the strength and resilience of the human spirit. Overcoming the psychological challenges of living on Mars will be as important as overcoming the physical ones, requiring a deep understanding of human psychology and a commitment to nurturing the mental health and well-being of the Martian pioneers. The prospect of colonizing Mars, once science fiction, is now a tangible pursuit driven by innovation and human ambition. Establishing a permanent human presence on Mars marks our transition to a multiplanetary species. It represents a triumph of human ingenuity and a new era for humanity. This achievement redefines our place in the cosmos, shifting our perspective to pioneers of a multiplanetary civilization. Mars colonization compels us to confront fundamental questions about our future. The knowledge gained could solve pressing problems on Earth. Innovations from Mars colonization could pave the way for a sustainable future. As we venture further into the cosmos, it is imperative that we proceed with caution, guided by ethical considerations and a deep respect for the sanctity of life. The colonization of Mars raises profound ethical questions about our responsibility to protect potential indigenous life, to preserve the pristine Martian environment, and to ensure that the pursuit of a multiplanetary future benefits all of humanity. Before establishing a permanent presence on Mars, it is crucial to determine whether life, even in microbial form, currently exists on the planet. The discovery of Martian life, however primitive, would have profound implications for our understanding of the origins and prevalence of life in the universe, necessitating a careful reassessment of our colonization plans to avoid any potential contamination or harm. Even in the absence of current Martian life, the preservation of the Martian environment for future generations, both human and potentially extraterrestrial, is paramount. Sustainable practices such as minimizing our footprint, utilizing in situ resources responsibly, and avoiding the introduction of harmful contaminants will be crucial for ensuring that Mars remains a pristine environment for scientific exploration and potential future habitation. Furthermore, the colonization of Mars should be a global endeavor, guided by international cooperation and a commitment to equity and shared benefits. The resources and opportunities presented by a multiplanetary future should be accessible to all of humanity, fostering collaboration and understanding rather than competition and division. The pursuit of Mars colonization offers a unique opportunity for introspection, holding a mirror to our own world. It prompts us to examine our values, priorities, and place in the universe. As we strive to create a new home on Mars, we confront Earth's challenges. Solutions for Mars, like renewable energy and waste management, could help create a sustainable future on Earth. Mars colonization fosters global cooperation, uniting nations in a common goal. It reminds us of humanity's indomitable spirit and thirst for exploration. The journey to Mars is about embarking on a transformative journey, shaping the future of humanity. The Martian legacy will be written in the knowledge gained, technologies developed, and the spirit of exploration. Imagine children born on Mars, their imaginations ignited by the pioneers who came before them. Exploring canyons and volcanoes, conducting research, pushing human knowledge further. Colonizing Mars is a stepping stone to a spacefaring civilization, exploring beyond our solar system. Lessons from Mars will pave the way for ambitious missions, expanding our understanding of the universe. The Martian legacy will be one of courage, ingenuity, and determination, a testament to the human spirit and our quest to explore the unknown, securing a future among the stars. The journey to Mars transforms humanity.